Joel Story 2.1. First of the respiratory system. The respiratory system has many responses it needs in order to keep the body functioning healthy. All these responses go to the respiratory control center, which is located in the medulla oblongata in the brain. These responses then get sent to the respiratory muscles and organs to either change certain factors or maintain an already healthy state. These responses can be sent from things such as chemoreceptors, which monitor levels of pH in the blood, which is controlled by the amount of CO2 being inhaled or exhaled by the respiratory system. Also, there are receptors such as thermoreceptors, which monitor the temperature of the blood and send these responses to the respiratory control center. All these responses helped the respiratory system to function in terms of energy systems and in general. Respiratory dynamics. Ventilation equals breathing rate times tidal volume. Ventilation changes with exercise due to the fact that the factors that make up ventilation, which are breathing rate and tidal volume, also change with when someone begins to exercise. For example, exercise will increase breathing rate as a person needs more oxygen in their body to supply all their working muscles with oxygen when exercising. As well as this, tidal volume will also increase when someone begins to exercise. This was clear with both clients when taking part in the multi-stage fitness test and the Wingate test, as when they began to exercise, breathing rate and tidal volume both increased, which meant after the exercise was finished, both breathing rate, tidal volume and overall ventilation increased to levels that we expected to see. Forced breathing mechanisms and control. In order to allow ventilation to increase when exercising, the respiratory system has certain controls and breathing mechanisms. These consist of things like the contraction of the internal intercostal muscles, as well as flattening of the diaphragm in order to allow the amount of air in the lungs to increase and therefore enable the ventilation to increase. MMPVA is used in both inspiration and expiration in exercise. This stands for movement, muscles, volume, pressure, and air movement, airflow. This is because the process allows an increase in volume in the thoracic cavity during inhalation, which is needed during exercise. As well as this, the process during exhalation makes sure to expel all the air in the thoracic cavity, as this is needed during exercise for maximum inhale and exhalation. When exercising, the accessory muscles are used during the inhalation part. These muscles consist of the pectorals and the lats, as well as others. These, alongside the internal intercostal muscles, help the ribs to move up and out even further to help provide more space in the thoracic cavity for a deeper inhalation. Receptors such as chemoreceptors link in with the respiratory system in order to help communicate and respond as breathing mechanisms to control respiration. For example, chemoreceptors control the pH of the blood, and if the blood level is too high or low, these receptors will send an impulse to the respiratory control center, which will then adjust the ventilation in order to correct the levels of pH. All receptors of the respiratory system will send their feedback to the medulla oblongata, where the respiratory control center is located. This is where the responses come from, as these responses are sent from certain parts of the brain to the respiratory muscles and organs to allow the correct change to be or not to be made. The Valsalva maneuver. Performing the Valsalva maneuver tests the body's ability to compensate for changes in the amount of blood that returns to the heart. This is known as preload. The changes in heart rate and blood pressure observed during this test are regulated by the autonomic nervous system. The Valsalva maneuver is a particular way of breathing that increases pressure in the chest. It causes various effects in the body, including changes in the heart rate and blood pressure. People may perform the maneuver regularly without knowing. For example, they may use it when they push to imitate a bowel movement. However, this technique can also be beneficial when people use it intentionally, as it can regulate heart rhythms and help the ears to pop. This could have been used during the first Wingate test, as this test requires maximal exercise and therefore would mean that someone taking part could perform this method in order to achieve their best without even realizing. This method is useful for activities that require one very intense maximal activity. Therefore, it would not be used in the multi-stage fitness test, but could be used in the Wingate test or other activities such as squats. Above here in the investigation data analysis, we can see graphs for breathing rate in the Wingate test and the multi-stage fitness test. At the beginning of the graphs, we can see a pre-test measurement, which is higher than a resting measurement, which may seem unusual. However, this is due to the fact that there is such thing as an anticipatory raise, where a client may be nervous or anticipating the fact that they are about to exercise. Therefore, breathing rate will increase itself before doing the test to help cope when the test takes place. The reason the breathing rate changes is due to the responses the receptors send to the respiratory control center, which influences the rate of breathing. The reason this increases as the test goes on is due to the fact the body needs to supply more oxygen to the working muscles, as this test is working aerobically for a long period of time. This is apparent in the data recordings, as the client's breathing rate at the end of both tests are the highest, which is how the graph should look. In the Wingate test, we can see that the post-test breathing rate is a lot higher than the pre-test, which is what we would expect, as we only took 2 measurements, one before and one after, as this was a very quick maximal exercise test, which means that the body would be working as hard as it could, and therefore breathing rate would be as high as, well, very high, which is what we expect to see, due to the fact that the body would need a lot of oxygen. In the multi-stage fitness graph, we see a gradual increase throughout each stage, which is also what we'd expect to see as you begin to work harder and harder, and the muscles are beginning to need more oxygen to carry on during the test. In terms of sport application analysis in the respiratory system, this is crucial in order for you to perform your best throughout a sporting event. For example, a game of football requires the respiratory system a lot in order for the body to function throughout the whole game. Also, football requires running, walking and sprinting. The respiratory system allows this to happen through gas exchange, which occurs in the blood to provide oxygen. Without oxygenated blood, a footballer would be unable to run for over 30 seconds. This means that in terms of sport, the respiratory system working and having correct responses and receptors is vital. This is due to the fact that internal and external respiration not only provide the body with oxygen in order to work and allow the muscles to work during a football game, but also this expels waste products from the body such as carbon dioxide, which stops the bodies from functioning efficiently and would make a football game very challenging if it was not removed. Therefore, the respiratory system is very needed during a football game, as this provides the muscles with oxygen and the blood and removes waste products so that the body can work and go through all the different stages in a football game, such as sprinting during a counter attack, or jogging to get back in position, or walking when the ball is out of play and you're taking a breather.